All right, this is Atimise Maths Academy, where mathematics is being made easy. On today, we are going on a series. The topic is sets. So this topic will really go far in our studies. Okay, now let's talk about the definition of set. Definition of set. We say set is a collection of well-defined objects of a truth. For a set to be set, it must be well-defined. It must be noticed that yes, this is a set, like a set of a classroom. What are the things you can find inside a classroom? You can see your table, you can see your chair, you can see your blackboard, your marker board. You know, all these things are things that made up the set. So it is well defined and it is well stated that this is a classroom. So that well defined they are talking about, when you collect all these elements, the elements are like your chair, your table, your fan, that made up a classroom. Since it is made up of a classroom, and these are the characteristics that made up a class, it is said that it is well what defined. So the objects there now, the object are the elements that made up that set, the things we can find inside the set. So a set is a collection of well-defined objects. Now, anytime we want to name a set, we use capital letter. Don't use small letter in naming of a set. But the elements inside the set, just like, for example, inside a classroom, what are the things you can find inside the classroom? It is called the elements. So the elements are you can use small letters, you can use numbers, but in naming of a set, you usually use capital letters, alphabet, capital letters. Okay, that's why I say we shall use capital letters. X, this is a capital letter X, Y, capital letter Z, etc. There are many, from A to Z, to denote sets. While small letter, just like I told you, for example, if you want to name a set, something like this, if you want to name a set, then you use a curve bracket, maybe A, comma, B, comma, C, something like this. You see now, you observe that this is the set. The set A has an element A, B, C. But the A, B, C there, they are small letters. They are named after the elements or members. So we say why small letters X, Y, Z, etc. are used to denote elements or members. What is inside this set? What is inside set A is small letter A, small letter B, small letter C. So it is well defined. A mathematician will always know that this is a set because it is what? Well defined. Now let's proceed. Now, either you use the word for what is inside this equal bracket. What you can use either elements or members. So if I say members of, elements of, just assume A is a classroom, because we are familiar with what a classroom is. Or if A is a field, what are the things you can find in a field? You can find players, people that play ball, the people that kick the ball in a football field, in a match. They are called the members or element of. What if it is a classroom? This A is a classroom. Then the collection of the class students, the tables, the chair is the elements. So A can be chair, B can be table, C can be students. So these are the things that made up a classroom. But if it is not well defined, what if I decide to use something that is not well defined, like I went and used capital letter A, capital, it is not well defined because you don't use capital letter except in a complex format. But in this our secondary school level, and I think even in the university, most of the cases we follow this principle, except you go advanced. Okay, now let's proceed. When an element X, listen, I want to elaborate more on what I'm explaining. When an element X belongs to a set X, remember this set X is a capital letter. Why this one is a member, is an element. We write X contain. This is a symbol that represents contain. It's a member of. The anytime you see this symbol, just know it means it contains or it's a member of. X contain in X. That is, X is a member of X, or is an element of X, or is a family of X, and says that X, now what I want to explain here, it says that X is a member or element of x. Remember, the member there is a small letter, the set there is a capital letter. Now, what if x is not a member? What happens if x is not a member or element of x? How do you write it? We write x is not an element, or x is not a member of x. That means it doesn't add to the family. For example, now, do we see anything like 1 inside this element? No. That means if I want to write that, okay, 1 is not found in A, I will write it like this: 1 is not a member of A. Simple and short. So we use this as a symbol to make it more simpler. Now let's come further. I said we write x is not a member of x. So I will write it in a written format. I say, and says that x does not belong to x. That is what this symbol simply means. So instead of it to write all these big languages, just write x is not a member of x. That is just the definition. Now let's take one example. I want to explain more. Example 1. If x, remember, anytime you want to name a set, it always comes first. If x is the set of all prime numbers. Prime numbers. What are prime numbers? Prime numbers are those numbers that have only 2 factors. What are these 2 factors? 1 and itself. Do you understand? So we can identify those numbers that only 1 can divide them, and then they can divide themselves. 2 cannot divide them. Anything that comes about 2, you enter even numbers. And most of the odd numbers are not prime numbers. Like 9 is a what? It's an odd number, but it's not a prime number because 3 can divide 9. But this case of prime number, only 1 and itself. So now let's consider. So most of the time, set use language format instead of numbers. Like this one now, they have entered prime number. So as a student, you need to know what a prime number is, very important, what odd number is, very important, and what even number is. So in this case, we have touched prime number, so I will explain a little bit of prime number as we go down. Now let's check. If x is the set of all prime numbers, and p is 7, observe, p is 7. Now, is 7, the question you ask yourself, is 7 a prime number? Yes, of course, it's a prime number. Then what will you now say? Then p contains in x. You can find p because p here is 7, is a prime number, so it can be found on this set. So how do you go about it? What if a is equal to 6? 6 is an even number because 2 can divide 6. And the definition of a prime number says 1 and itself. So therefore, I will say then a is not a member, is not a prime number. If x is the prime number, that means a is not a prime number because a is an even number. You understand? So set is very, very sweet when you understand the terms and the concept. Now let's proceed. I want to explain what a prime number is. You know, prime number you have been taught in your primary school, secondary school, even in university, you still be using prime number as mathematics is concerned. Now let's go further. A prime number, what is a prime number? A prime number is a whole number greater than 1. It must be greater than 1. Observe, it must be greater than 1. That has only 2 factors. That has only 2 factors. What are the 2 factors? 1 and itself. 1 and itself. So these are examples. This is the beginning of a prime number. So in case you don't know what the prime number is, after this video, I believe you understand what the prime number is. So you start by saying 2. 2 is a prime number. 2 is a prime number because only 1 can divide 2 and 2 can divide 2. So itself and 1 alone. You understand? Now this 2 now looks as if it's an even number because when you come to even number, you say 2, 4, 6, 8, 10. Like even number, we even have 0. 0 is an even number because by the time you divide 0 by 2, you still have 0. So we'll come to that aspect anytime we elaborate on a video concerning even number. But this is a prime number. So anytime you want to start a prime number, you start with 2, 3, 5, 7. Now, 11 is not there. 9 is not there. 9 is an odd number. But 9 can be divided by 3. That was why we do not include it here. So that is why most of the prime numbers can be found in the what? Odd numbers, but most of the odd numbers cannot be seen in the prime numbers. Okay? So, like what I mean is that 9 cannot be found here, but 9 can be found in an odd number, 11 can be found in an odd number. So you have 11, 13 as it proceeds. So observe, after 2, you observe that all your 3s, all your 5, 7, your 1, 3, 7, 9, 3, 9, 1, 7. I'm just talking about the last part of it. 37, 7, 1, 3. You observe that it repeats itself. It's called what? Prime numbers. So let me just do the summary of everything. So set is a well-defined object. So once a set is given, like this example 1 now, the set is well-defined because it's talking about prime numbers. So you need to know what a prime number is for you to be able to solve this problem. So thank you very much. This is Atimise Maths Academy, where maths is being made easy. Subscribe to my YouTube channel. Go online. In case anything you don't understand, you can drop your comment below. Thank you very much.